All right. So my sister's in quarantine with me, so that's part of the fun is quarantine a quarter of our house. But so hello everyone. Hi. So my name is Daniel. I am a PhD student at Virginia Tech, and currently my PhD is in data science education pedagogy, especially with regard to medical, biomedical, and the health sciences. Currently my advisor is Ann Brown, and I'm working at Virginia Tech through DataBridge, and she also has a wet lab. Oh, sorry, not a wet lab, a molecular dynamics lab as well. This past summer, so summer 2019, I was an RStudio intern where I worked on a package called GRADETHIS, which is what this talk is about. And whoops. And so GRADETHIS is essentially a code grader for learnr documents. So if you are a instructor or a teacher and you're using R and you want to give out assignments, between learnr and GRADETHIS is a very new set of tools that we'll be talking about. And this is an R talk, and I'm sort of like known for like always bringing up Python in R talks and R in Python talks. So I also wrote a book called Pandas for Everyone, which is essentially a walkthrough of learning Python from the data analytics side. So this past summer, I was an RStudio intern, and I worked with Barrett Sherlerke and Garrett Gurlemund. And I guess the main takeaway is I am a user of R and not a developer. And one of the nice things, or one of the things I learned over internship is sort of how to become more of a developer on the R side. So how do you create more robust packages and stuff like that? And I totally forgot to start my timer, so give me 1 second. All right. And if you want to read more about my time as an intern, there's a bunch of blog posts that I've written over the past couple months. And so over the summer, I worked on the education and Shiny team. And so it was kind of pretty cool to be in regular contact with all of the education team. We met pretty much once a week. And then on the Shiny team, they go through agile. They have a very agile workflow. And so we pretty much met every day for like 15 minutes. And one of the coolest things, as you can imagine, is when you become part of the RStudio system, they have this internal Slack channel. And if you're like me, this very excited intern, you go down all of the channel lists and you just subscribe to everything. That seems interesting. And this is sort of my interaction with Hadley of being super excited about like a Shiny book and then immediately being told like I don't belong there. And so I left. So but this talk is about learnr interactive tutorials. And so learnr is a system that allows you to have prose text along with a place for a user, in this case, a student, to type and execute R code. And so you can have narrative figures, illustrations, you have code exercises, you can have quizzes, you can embed videos, you can even have small Shiny applications. That's all handled under a learnr document. So to create a learnr tutorial, there was a few talks already about R Markdown. And so in the YAML header, the main differences is we use a learnr tutorial as the output, and you have to use Shiny pre-rendered. Essentially just caches a whole bunch of stuff from the Shiny end, because learnr is really it's also a Shiny application under the hood. And the main other changes you need to make, well, you have to load up the library, and inside your R chunk, all you really need is exercise equals true, and that block of code will become a learnr exercise. And what that looks like is, so this is a snapshot of what your R Markdown code would look like. And then on the bottom, this is what shows up on the other end. And so you can see here on the top, you can have any type of prose text, Markdown text that you want. And then on the bottom, the learnr portion is this block right here that gives you a place to run and execute code. And so we can do more with that. There is another library that sort of, this was all done pretty much like second half of last year. So it's super new. There's a JavaScript library called sortable.js, And Andre has ported that over into the R side. And so you can also have a sortable widget, just like a regular Shiny widget, that lets you sort things. This is useful for education purposes, but also when you're building your own Shiny apps, you can imagine you have, a ggplot figure, and you can have the end user like literally drag and drop components that they want for the x-axis or the y-axis, right? From the education side, one step beyond a sortable list is something called a Parsons problem. And so what this does is this is a very special type of programming problem that reduces the cognitive load for the student. So they don't have to write the actual code. So there's fewer chances of getting syntax errors, but all they have to do is put the code in the right order. And so this tests their ability on like, are they getting the concepts right? We'll worry about syntax at another time. And what a Parsons problem looks like is essentially, it's a sortable list. And you can see like, hey, if we're trying to take a data set, mutate it, summarize, and print, what you're really trying to do is like, hey, I want a grouped aggregate, for example. And all they need to know is what order they need to put the code in. It pretty much writes the code for you, or you're really putting the code in the right order. But then the student doesn't have to worry about typing the wrong code. Syntax issues, that's implementation, and that can be tested or worked on at a later time. And so these are all tools for a teacher if you're trying to get students to learn. But what about the actual grading portion? You want to be able to give students some kind of feedback. And at the very least, you want to be able to tell them like what and where things went wrong. And so there's a few ways you can do this. One way when you're grading examples is just looking at the result, right? So I was a TA before, and when you're checking homework, you're pretty much checking to see if the answer is right, and then you like see how they got the answer right or wrong. And this works, but sometimes when you're programming, you're trying to teach like an actual function, right? So like, for example, 3 + 3 is 6, which is really the same thing as 2 × 3. But if you're really trying to teach multiplication, then the addition way of getting the same answer doesn't really work. And that's one of the limitations about just looking at the result. Another way you can do it is look at the code, except looking at the code is super strict, right? So 3 + 3 is not the same thing as 2 × 3, which is right. But the same thing, if you're just looking at code, for example, apply, and if you put in those parameters, if you treat the code almost like a string, those two things aren't going to be the same, even though they're the same exact code. Even more so for the mean, there's a default argument called NA_RM = false. And if the student just puts NA.RM = false, that's going to be wrong too, because the code doesn't match up. So another way of looking at the code is looking at something called the abstract syntax tree. And so the AST is a graphical representation of how your code is going to be executed by R. And every single programming language has some version of this. And so if we have a function call that is the log of the exponent of 3, the AST looks like this. 3 gets passed into the EXP function, and that result gets passed into log. And so if we change that value, change the 3 into a 2, you can see that these two trees are different. And then if we put in arguments, you can see, or parameters, you can see like how the tree gets built up. And essentially one of the features of GRADETHIS is comparing these trees, right? You can immediately see where things are going wrong when you have the AST. This is a graphical representation of what's going on. The implementation is a little bit harder, but that's essentially the concept of what's going on under the hood of GRADETHIS. And so GRADETHIS is an auto-grading system that can be used with learnr documents. You can use it to check your answer. You can use it to check the code, which is using that AST way of checking code. Just another side note, in learnr, each exercise is completely independent from the other, so you can't really carry variables from one exercise to another. If there is like kind of a progression, you almost have to copy paste code that way. And that was really just a implementation decision just to clear out the environment, because then the instructor has to worry about what's tainting or being in the environment. And so essentially the decision was, let's just clear everything on each exercise. And the cool thing about GRADETHIS is it's really the ability to give the student more formative feedback. So that's really the really cool thing about this package. And so why we have learned the learnr package, why not GRADETHIS? Well, the short answer is it was originally named GRADETHIS, and then like during the first couple of weeks of my internship, someone from UVA took the name in crayon. So we have this whole issue of like, how do we rename this function? So what does formative feedback look like? So if we have the answer where it's like this, the answer is supposed to be something else, like take the square root of the log of number 2, and if the student just puts in 2, GRADETHIS now gives you this submit answer button. So that's what GRADETHIS gives you. And then for formative feedback, you get a response that's not just like, hey, the answer is wrong. It's like, I expected a call to square root where you wrote 2, and then some kind of like encouragement or praise, right? And so that part there is trying to help new people into R by telling them where their code is going wrong versus like, here's this really like cryptic error message that if you're really new to R, like you're just terrified. But when you get used to it, then you'll understand what the error messages mean. And so how does learnr work with GRADETHIS? Well, you have a base chunk, and then you have the same base chunk name, and then that chunk name has a dash check. And that tells, and within dash check, you get to pick, how do you want the code to be graded? Are you looking at the solution, which is just looking at the final result? Then you use the GRADETHIS grade result function. Are you looking at the code? Or are you trying to grade the code or the AST way? Then you need to use the grade code function that's provided by GRADETHIS. If you're using the grade code function, you also have to provide an additional base dash solution chunk because that's where the instructor puts their code to be marked. If you're testing functions, there's also another way to essentially run a suite of unit tests, and you can run grade conditions. And there's the ability to have hints as well for each exercise. And so what does this all look like? So we can have our learnr exercise, and my formatting is a little bit off. And so you can have like this scaffolding question in the learnr document. And we, for example, want the student to put log exp of 3, and you can add in these little dashes. That's part of just learnr not executing code. So what does grade result look like? Well, we have that learnr piece up there. We can have a hint block right here. And here is the dash check. So you see that our code block is named addition. We have the addition dash hint, and then addition dash check. And in dash check, we use the grade result function. And in grade result, essentially, you pass it a series of pass if, fail if statements. And the first one that it matches will give that result. So if the answer is supposed to be equal to 3, we can check to see if the student result is equal to 3. And if it matches this, then we pass, and then we get a message that says yay to our student. If you know that there's a trick to this question, and if the result is a specific answer, and you want to be able to catch that and return information, you can do that as well by using fail if this condition matches. So for example, if it matches a 2, then give this as a response, because you as an instructor are expecting that kind of error. And then these are 3 different ways. You can use the tilde, the formula notation, the function notation, or just straight up put in a value. If you've used the per package before, that same notation with the map calls, that's consistent within GRADETHIS as well. And then if you want to grade code, then remember you have to use this dash solution chunk, so the same thing before. And in dash solution, the instructor puts in, this is the code that I want to be used to grade. And then in the check call, all you say is grade code. You can also grade conditions. So grading conditions is very similar to grading the result. So the body really looks exactly the same. Instead of grade result, you're using grade conditions, and this will go through all of them. And essentially what you get back is how many of all those conditions were passed. So if you're trying to test like a function that a student is writing, you can write a whole bunch of unit tests, and it'll be something like, hey, you got 8 out of 8 checks correct, or you got 7 out of the 8 checks correct, et cetera, et cetera. So the chunk names do matter. So like I mentioned, we have the base name. So in this case, it's called addition. And if we want to add a hint, then we say addition dash hint. The solution code is dash solution, and the check code is that base dash check, right? So the chunk names very much do matter. All of those other portions to the right of the dash is how learnr is grouping those chunks together. So the problem, or the annoying thing is because that means that you have to label every single chunk that you write, and that can get tedious. And also, knitter chunks need to be unique, otherwise it won't knit. And so within GRADETHIS, there's also this add-on that will just put out a skeleton for you, and it'll generate a random chunk name of length 16. We just came from a bioinformatics talk, so 16 is a very special number in that kind of world, and that's sort of the reason why I picked it. And so this way you can very quickly add just this boilerplate stuff and then just write your code. One of the things I did learn about over the summer is be careful with the double equal sign. You can call it a bug or an inconsistency or improper documentation, whatever euphemism you want, besides calling it bug, because the R core people might find that offensive. But there is a bug in the double equal sign that I found, and I wrote about it over the summer. And essentially, when you're working or grading code pieces like expressions, use the identical or all.equal function, do not use the double equal sign. And you'll notice that these two lines, they're exactly the same except for this 1 and 2. But if you check if u is equal to s, you get true. And the long story short is anything after 60 characters doesn't even get checked when you use double equals when you pass in an expression. It'll work if you pass in a string, but we're working with quoted expressions. So the dev guide for learnr versus GRADETHIS. Learnr is responsible for all of the handling of bits and pieces, and GRADETHIS is responsible for just checking the solution. So there is a checker, a learnr checker. And so at the very beginning of a learnr document, you set this exercise checker equals learnr checker. And this is the entry point from learnr into GRADETHIS. And so if you want to write your own custom grading function for a learnr document, this is the entry point that you would need. And this function takes care of all of those chunk bits and then passes it on into the GRADETHIS package functions. And so that means that you can actually use GRADETHIS as a standalone code grader. So if we library GRADETHIS, you can have a student solution that's equal to 5. And for just checking the result, you can straight up use the GRADETHIS grade result and your series of pass-if statements. And then part of the reason, you'll see then the remnants of like learnr, args, et cetera, GRADETHIS used to be part of learnr and it got spun out of as its own separate package. So there's small remnants of that, especially in the variable names in our functions. But what you get back is this list object where you get a message and then whether or not the answer is right or wrong. And that's really all GRADETHIS is doing, is giving you a message and telling you if the solution or the student's code was right or wrong. And so you can do this with grading the code as well. So let's say we have student code and solution code. Student passes in square root exponentiate of 3. And then the solution or the teacher's code is square root of log of 2. You can run the grade code function directly, pass in. So this is one of the remnants of GRADER being instead of GRADETHIS. One of these days, this will change. So this package hasn't made it to CRAN yet. So be very aware that things might change if you are going to use it for production. But then you can get a message that says, I expected a call to log where you wrote exp3. Let's try again. And the solutions are wrong. And so one of the things that I've learned over the summer was going from a user of R to like an R developer. And so one of the things that I've learned was this tidyeval or eval tidy. And so for the last couple of minutes, we'll very quickly go over some of the major takeaways that I've learned. First thing is a formula, you mainly see it when you're fitting models, but all it's really doing is capturing an expression with an environment. So if we do something like tilde x bracket caret 2, all it's doing is saving exponentiate 2. It's not really doing anything with it. And so if we really wanted the caret 2, we can take that formula notation, get the second argument, and that's everything. That's the entire expression. The first argument is just a tilde. So, and then how does tidyeval work? Essentially, we run this eval tidy function. We give it the expression that we want, so x to the second power, and then we pass in a bunch of data arguments. So let's say we want x to be 15. and then we can give it the global environment. We need some kind of environment. And then we can say, okay, you have this expression x caret 2. Here are all the data bits for you that you need. Now evaluate the code, and you get 255. And so what does this look like inside GRADETHIS? So this is actual code in the function. I have a switch statement that tells me whether or not the user passed in a formula notation, a function notation, or just a value. And right here is literally the same concept from the previous thing. So that's why you have dot result or dot. You probably saw just the singular dot when you're working with the per library, and it's really just saying, hey, just treat this character string dot as this other value and then execute that expression. So that's how that part works. Another thing that I've learned was lapply is good. So if we have a vector 1 to 10, we can say log everything with base equals 10, and we get a list. That's great. The other thing I learned was sapply is bad because you're not guaranteed stable output from sapply. Could it be a list or is it a vector? You kind of don't know. It depends on what you feed into it. And that's kind of dangerous from a package developer standpoint of view. So vapply is way better because in vapply, you literally specify what is the numerical type, vector type that you want and how many elements in each piece. And so it's super consistent. And if it returns anything different, it'll error out. And so that's how you make your code a lot more robust. And so that is the end of my talk. So the slides and everything are already on GitHub. And so my time's definitely up because I started my timer late. So thanks.
Thank you so much, Dan.